Have you ever noticed how your phone says full bars, but the video still buffers like it's 2009? Well, here's the uncomfortable truth. Wi-Fi isn't really a pipe. It's more like a polite conversation in a crowded room. Except the room is invisible, everyone's talking over the radio, and your neighbor's router is also in the room. Today I'm going to talk about how Wi-Fi actually works, what's happening between your phone, your router, and the air, why apartments can be harder than houses, and what Wi-Fi 6 or Wi-Fi 7 actually buys you in normal human terms. Welcome back to the Tyler Woodward Project. I'm Tyler, a broadcast engineer, Linux nerd, and the guy who can't hear the words, "It's probably the internet," without asking, all right, but which part? Today is Wi-Fi in plain English, with just enough nerdiness to make you dangerous, but hopefully in a good way. We'll hit three things: how Wi-Fi works, what Wi-Fi standards mean, and why houses versus apartments can change the whole game. By the end of this, you'll know why more bars doesn't always mean more speed, and you'll have a simple mental model for fixing most home Wi-Fi problems without turning your living room into a science fair project. Let's start with the simplest true sentence about Wi-Fi. It's radio. Your router, or more accurately, your Wi-Fi access point, sends and receives radio signals. And your phone and laptop have tiny little radios in them that do the same thing. The air around you is the shared medium. There is no cable between you and your phone or the router. So instead of everyone gets their own lane, it's everyone shares the same intersection. Now, let's do a quick vocabulary sanity check. Your SSID is the network name you see in that list. The password is part of how your traffic gets encrypted, usually with WPA2 or WPA3, and your router is often doing multiple jobs: Wi-Fi access point, Ethernet switch, firewall, and the box that connects your home to the internet. When you connect, your device doesn't just start blasting data out into the void, it scans for networks, picks one, authenticates, and associates. Basically, it's saying, "Hi, I'm this device and I'd like to join the network." Then the real-world behavior kicks in. Wi-Fi takes turns. It's not like a wire where it feels like you have a dedicated connection all the time. Wi-Fi is designed to be polite. Your device listens first. If it hears someone else talking on that channel, it'll wait. If it sounds quiet, it'll begin talking. That wait your turn behavior is why Wi-Fi can feel amazing at 3 o'clock in the morning, but mysteriously awful at 7 o'clock at night. The air got busier, so you're waiting a little more. And yes, sometimes two devices talk at nearly the same moment and can, step on each other. Modern Wi-Fi is better at dealing with that, but the key idea stays the same. Airtime is a limited resource. So, if your neighbor is streaming, you're streaming on your smart TV, and your laptop is downloading a huge game update from, say, Steam, you're not just using bandwidth, you're competing for turns. What this means for normal people: your internet plan can be the fastest in the neighborhood. And your Wi-Fi, it can still be the bottleneck, because the bottleneck is the shared air. Wi-Fi runs on a few different bands. Most people deal with 3, 2.4, 5, and now the new kid on the block, 6 GHz. 2.4 GHz tends to go farther, and it can push through walls a little better, but it's crowded and also shares space with your microwave. And, well, it's often slower in practice. It's the old school one. 5 gigahertz is usually faster and has more room to work with, but it doesn't go as far or through walls as good as 2.4. 6 gigahertz, that new kid on the block, is what you get with Wi-Fi 6E and Wi-Fi 7 capable gear. It can be great because it's often less crowded, at least right now, but it still follows physics. Distance and walls still matter. Within those bands, Wi-Fi uses channels, like lanes on a highway. Modern Wi-Fi can also use wider lanes, which can increase speed if the air is clean. But in a crowded apartment building, wider can backfire. You overlap more with your neighbors, so you spend more time waiting your turn and retrying. It's like trying to host a quiet conversation while taking up half the room. Wi-Fi gets weaker with distance. Walls, floors, metal ductwork, mirrors, all of those can weaken the signal or distort the signal. And, well, signals also bounce, which can create random dead spots in your home where you swear Wi-Fi should work, but it doesn't. I've got a room like that in my own house, one of the bathrooms upstairs. This is classic RF stuff. And broadcast engineering, you learn fast that reflections and weird nulls, they're real. And moving a receiver 2 feet can totally change the result. Home Wi-Fi has, well, the same physics. It's just lower power and smaller antennas. A Wi-Fi standard is basically, it's a rule book for how devices share airtime and how efficiently they can move data through the shared air. It's not just top speed, it's also how well does this work when your home has a ton of devices or when your apartment has 50 neighboring networks. Now, let's connect that to the Wi-Fi numbers you see on that box at Best Buy. Wi-Fi 5, Wi-Fi 6, Wi-Fi 6E, Wi-Fi 7, and why apartments and houses behave so differently. Apartments can feel cursed because you're not just sharing Wi-Fi with yourself, you're sharing the same air with everyone around you. In a house, you usually have a coverage problem, distance, floors, and a lot of walls. In an apartment, coverage is often fine, but contention can be brutal because there are so many other networks close by. That's why you can still have full bars and still get buffering on YouTube. Your device is hearing a ton of other traffic around you. And remember earlier when we talked about waiting its turn? Well, it's sitting there politely waiting its turn. What this means for normal people, in apartments, the problem is often crowding, not signal strength. Here's the standards in layman terms. Wi-Fi 4 is older, but it was the start of the modern feeling home Wi-Fi for a lot of people. If you're still on very old gear, upgrading can feel absolutely amazing. Wi-Fi 5 pushed the speed hard, mostly by leaning into that 5 gigahertz band. It can be great, but it's not specifically tuned for a living room full of devices all shouting at once. Wi-Fi 6 is the efficiency and crowd control upgrade. It's built to handle a lot of devices more smoothly so things feel more responsive when everyone's online at the same time. Wi-Fi 6E is Wi-Fi 6 plus access to that 6 gigahertz band. Think of it like opening a fresh highway next to a traffic jam. In many apartments, that can be a real noticeable improvement if your devices support it and you're close enough to the access point. Wi-Fi 7 pushes capacity and latency improvements farther, but here's the reality check. You only get the benefits if your phone, your laptop, and your devices support Wi-Fi 7 features. Here's the big difference in approach. In a house, you usually win by improving coverage. That means better placement and often more than one access point. In an apartment, you usually win by improving airtime quality. That means using less crowded bands where possible and avoiding settings that cause you to overlap with everyone else. Okay, let's turn all of this information into a checklist you can actually use. First, move the access point before you buy anything. Put it in a higher, more central location and out in the open. If it's shoved behind your TV, inside a cabinet, or tucked in the corner because that's where the modem is, you're starting the race with ankle weights. Second, match the band for the job. Use 2.4 for long range and simple devices like your IoT stuff, your Ring cameras, and your smart outlets. But use 5 for the most performance devices. And if you have 6 GHz available, use it for newer devices that care about speed and latency, especially in those apartments. Third, don't automatically choose the widest channel in the crowded places. In apartments, a narrower channel can be more stable because you overlap less with your neighbors. Fourth, if you need more coverage, add access points, ideally with a wired connection to them. A mesh system can help, but wired backhaul is the gold standard. Otherwise, that mesh point, it's also competing for airtime. Fifth, upgrade for efficiency, not marketing numbers. If your network has a lot of devices, Wi-Fi 6 is a solid quality of life upgrade. If you're in an apartment and you can swing it, Wi-Fi 6E can feel like escaping the chaos because of that 6 GHz band. If you only remember one thing from this episode, remember this. Wi-Fi problems are usually airtime problems. Either the signal is too weak where you are, or too many devices and neighbors are sharing the same air. So that's Wi-Fi. It's radio. It's shared, and newer standards mostly help you share the air more efficiently, especially in crowded environments. If you're in a house, think placement and coverage. If you're in an apartment, think about congestion and smarter band choices. Visit tylerwoodward.me, follow at tylerwoodward.me on Instagram and Threads, subscribe, and like the show on your favorite podcast platform. And if your Wi-Fi is still melting down after you tried all of these basics, congratulations. You've earned the right to start blaming your internet service provider, but only after we move the router out of that damn cabinet first.